Welcome back to PE Academy. So in this video, this is the second example we are going to be looking at under Coulomb's law. So I've just saved ourselves the stories of the question and just bring us the values that we actually need to answer this question. So we already know, I already picked out the value of our QA, QB, and then RA, RB. So the question is asking us that we should find RAB, that's the unit vector of RAB, and we should find the magnitude of RAB and the force exerted on QA by QB. Exactly. So depending on the question, it might come with quite a number of other stories. Just pick out the values and then you'll be good to go. So now let's do this. So the solution now. So for this now, we are starting with the I part, which is this. We are asked to look for the unit vector of RAB. So to do this now, we already know what our RA is, and then our RB, what our RB is. So now let's indicate the coordinates. This is for X, this is Y, and this is Z. Here also this is the X, Y, and then this is for Z. So for us to get RAB, so that is RAB is equals to, so that will be 6 minus 7 AX, okay, then plus, that's for the X coordinate, then for the Y, that will be 8, so this is 8 minus 5 AY, then plus minus 4 minus 8 AZ. Very good. So now let's tidy this up. So 6 minus 7, that will give us 13 AX. So don't forget this bar at the top. Then 8 minus 5, that will be plus 3 AY. And then minus 4 minus 8, that will give us minus 12 AZ. So with this now, we've been able to complete the first part of the question, which we are asked to find RAB, the unit vector RAB, our unit vector AB. Now, before I go to the second part now, just in case you are confused that, okay, we are asked to look for the unit vector AB, and we are subtracting the direction of B, or the coordinate of B from A, such that we are having 6 minus 7, 8 minus 5. You know, we are subtracting the value of A from that of B, and the question is saying, okay, RAB, is it not supposed to be minus 7 minus 6 or 5, then 5 minus 8? So if you are still confused about that, I'm going to explain that at the end of this video. Exactly. So just take notes. I'm going to explain that so that you don't get confused, so you know which to subtract from which. Exactly. So if you are given to find the unit vector of RAB, so that you know that, for you to understand that, okay, maybe it's going to be 6 minus 7, 6 minus minus 7, or minus 7 minus 6. Exactly. All right, so let's continue. So now let's look for the magnitude of the unit vector AB. So that's for the second part. So for that, it should look like this. So that will be RAB. So that's just the square root of whatever we get as the unit vector here. That will be 13 square plus 3 square plus minus 12 square. Okay, and that will give us, so 13 square will give us 169 plus 9, which is 3 square, and then plus, so minus 12 square, that will just give us 144. So with that, we are going to be having 169 plus 19 plus 144, and that should give us 332, and that will give us 17.94. So the unit is actually in meter. The question states that all of these are in meters. So in meters. So don't forget to put your units. All right. So we've answered the first two parts. Now let's answer the third one. So in the third part, you're asked to calculate the force exerted on B by A. So this also, I'll be explaining it at the end of this video. So force exerted on B by A. So how do you go ahead to calculate that? And what if it is force exerted on A by B? So you need to really understand the difference between all of these things. All right, so now let's go ahead. So for this now, since we are dealing with, we are asked to calculate force in terms of, in the vector form. So that means our F will be QA QB over 4 pi E naught. So 4 pi E naught. So multiply by the magnitude of AB, that's RAB square. Then multiply by the unit vector RA, RAB over the magnitude of that RAB. Okay, so that's the formula we are to use. All right, so now let's put in the values. So our QA, that's our charge at point A, is given as minus 50 microcoulombs, and that is same as minus 50 times 10 raised to power minus 6. And then QB is 60, which is equals to 60 times 10 raised to power minus 6. So you also have to take note of some of these units when you have kilo and when you have micro. If you have mega, some can be pico and some can be nano. Exactly. So you have to know what all of this. So since I mentioned it, let me just write it. So this will be times 10 raised to power 3. This is 10 raised to power minus 6. And then this is pico, is 10 raised to power minus 12. So that's for pico, 10 raised to power minus 12. Then for nano, which is n, is 10 raised to power minus 9. And then, so if it is capital M, that is mega, which is 10 raised to power 6. Exactly. And then if it is small m, that's milli, which is 10 raised to power minus 3. So you just need to take note of that. All right, so let's go back to the question. So our QA, like we rightly see here, is minus 10 raised to power minus 6, and our QB is 60 times 10 raised to power minus 6. So let's put in the values. So you're going to be having minus 50 times 10 raised to power minus 6, that's for QA. Then QB times 60 times 10 raised to power minus 6, then over 4 times, so our pi, let me use it, 3.142 times, then E naught. So in most cases, the value of your E naught will be given in your question, because E naught is a constant. And if it's not given, you can, like I've talked about it in the previous part of the video. So the value is 8.854 times 10 raised to power minus 12. Exactly. Then the magnitude of our RAB, if you should square it, now let's go back. So the magnitude of our RAB, where did you get it? Okay, this is it. So 19.94. All right, so which is 19.94, I mean 17.94 square. All right, so you can decide to put it as 17.94 square, or you just go ahead and put in this value 322, multiply by 322. Exactly. So because by the time you square the magnitude of the unit vector, it will give you the square, I mean whatever value is under the square root here. Exactly. All right, so that solves for this part. Then multiply by, so our RAB, which is our unit vector, and then we've gotten it, which is this value here, which is, so that's 13 AX plus 3AY minus 12 AZ. So that's 13 AX plus 3AY minus 12 AZ, then over the magnitude of the unit vector, so which we've gotten to be 17.94. 17.94. All right, so now our F. So now what you just have to do now is to type in all these values in calculator. So one thing I also need to mention here is that if you are typing in these values in your calculator, you have to be very careful. Exactly. So if you mix it, you might just get it all wrong. But let's just do this together so that at least maybe you might just get one or two things from it. So what I'll do is I'll put all the numerator in a bracket. Exactly. So that will be, we are having minus 50 times 10 raised to power minus 6. So times 10 raised to power minus 6. Then times 60 times 10 raised to power minus 6. So that's what we are having at the numerator. So let me just close that. Then divided by, let me open another bracket, 4 times 3.142, or I can just put it as 4 pi. That's 4 pi times 8.854 times 10 raised to power minus 12. Then times 322 times 322. So times 322. Alright, so now I can just close the brackets. So that's giving us minus 0.0837, and that's what it should be. So you can see how I was able to type everything correctly. So you have to be careful when typing it into your calculator. So this is how you go ahead, you type it in your calculator and to give you the answer. Okay, so now let's go back. So we've gotten this to be minus 0.0837. So multiply by. So what we are having here also, we are going to divide it. So that means we are going to divide 13 divided by, so that's 13 divided by 17.94. So that will give us 0.72. So let me just also put it in 4 decimal place. 7246 AX plus, so 3 divided by 17.94, that will be 0.1672 AY minus, so 12 divided by 17.94, that will give us 0.6689 AZ. Alright, so don't forget the bar at the top of those A. So let me try to close this bracket. Okay. Alright, so at the same time also you can divide this 0.0837 divided by 17.94, then you use it to multiply what we have here, so you still get the same answer. Alright, so what we'll do now is you just use this minus 0.0873 to multiply everything inside this bracket. So if you should do that, you are going to get minus 0.061 AX, then minus, so if you multiply this by this to give you 0.013 AY, then if you use minus 0.0837 to multiply minus 0.6689, so that will give you plus 0.056 AZ. So with this now, we've been able to get the value of the force that is being exerted by QB, the force exerted by, on QB by QA. So with that now, we've been able to answer the first, the second, and the third part of this question. So like I rightly said at the beginning of this video, I'm going to be explaining to you how do you know which you have to subtract from this, especially when you have to get the unit vector. So, but since it's a separate explanation, please, like I promised to do it at the end of this video, but I'm going to be doing it in a separate video, which is going to be the next one after this. So if you have any question or any comment with this solution, do let me know in the comment section. And if you find value, please give it a thumbs up, like, share, and subscribe to the channel. And I'll see you all in the next one, where I'm going to be explaining the RAB, how to know which and which you have to subtract from each other, exactly, and when this QB on QA or QA on QB. All right, so I'll see you all in that video. That'll be the next one. Thank you.